Hi everyone. So here we are doing the binary search part two. I hope you have watched my part one video. So I'll be extending few few more details on this part two video. Now let's see. So if you remember in part one, what I said, what are the identifications of binary search? First, it should be if the brute force should be the linear solution, linear search plus the space should be shorted one. Okay. So this was the first thing. Now listen guys. So if let's say for this example, there's a value k equals to 7, and what you have to find, you have to find the largest smaller value, the largest small value than 7. You know which is that? It is 5, the largest value in this array which is smaller than 7. Okay. Now the way is, what I say, like divide this space, like, and when you had decided for binary search, when you decided that I will go for binary search, the best thing is to divide this particular array into, or divide this structure into two parts. What I say two parts, the first part, let's say it has like two parts means, say that the first part and second part. So you have to decide which part your answer would be, which part your answer would be. And let's keep it like this, that in whichever part your answer lies, we will call that region favorable one. Okay, what I mean by this, here if you see, what you wanted value less than 7. Of course it should be the greatest value, but what was your uh, basic concern was value less than 7. Here which range gives you value less than 7? Of course this one. So let's call it favorable range, favorable. And the other range which is greater than equals to 7, even if it is equals to 7 and greater than as well, we are not concerned about it, because in question what we wanted, lesser than 7, like smaller than 7. Okay, so what we wanted is smaller than 7. So this range would be unfavorable, although you can call it the reverse. We just want to divide this search space into two portions, two parts. Now see guys, once you are done with this, once you are done with creating, converting this sort of a space like this, so forget about this. To calculate your answer, forget about this. It's just that, now see what you want. If you see this guys, what you want, you want the last favorable as your answer. That's it. This is what you want. Okay, here the 5 is the answer. And what was that last favorable? As I said, once you are done converting this thing to this sort of space, forget about these numbers, because these numbers may confuse you if you see them and try to implement binary search. But if you see only two things, favorable, unfavorable, it would be easy for you. Okay. So now let's try to see like how binary search will work into this. So as you know, first thing, as you know, that let's see this problem again here in this page. I'll come back to that page number one. So if you see k is equals to 7, as I divided this space into favorable, unfavorable. As I said, all the values lesser than k, this is favorable. All the values greater than equals to k, this is unfavorable. And guys, if you know, if you see this, if you are at favorable, where would you move? Because what you want the last favorable, the last favorable. So where would you go? Obviously you cannot go to left, obviously you cannot go to left, because your answer is in right. So where you have to move, you have to move right. To how to move right, you'll do L is equals to mid plus 1. If you keep L here, H here, what what is this? You have to push L towards right, and for this, if you land at any unfavorable, you cannot go to right. You have to always go to left of it, because obviously you want what, last favorable. So here you have to go H is equals to mid minus 1. Okay, so actually guys, this is what we thought of, like this is how we think, but actually all this magic happens due to this if and else. So all the values who are lesser than k, you'll move to their right, which means they will be favorable. Lesser than k will be favorable. So actually, you don't have to write this sort of array. This condition will handle this condition. If and else will handle this. Like they will themselves divide this search space into two parts. But what the thing is, the catch is the way you will think this. The way you will think this, because you have to write this. This condition will not come up on its own. You have to write this. So what I said, just think it in this way, just think it in this way and write the conditions properly, like the way you think, like lesser than k is favorable, greater than equals to k unfavorable. Now see guys, let's try to see this thing, that what you wanted like here, the lesser largest value lesser than 7, largest value lesser than 7. So what was your answer? 5. So this is the template of binary search that we always follow. Like this is how we do binary search. Okay, now if you see guys, there's one thing, because you have to return the largest value lesser than 7, and who is in this condition, if and else, who is giving you lesser than 7, lesser than k? Obviously if condition. So inside this if, you have to, like, let's keep a variable a and s. You have to make sure that you are not missing out this value, you are not missing out this value. So you have to make sure you would write a and s is equals to a of mid as well. A is equals to a of mid as well. You close this, then this else will come. So because what is this? Because you want this 5 as well. You want the 5 answer, because you just don't need to write like this binary search only, because you have to return some answer now. So and that will lie in this if condition, lesser than, because this answer lies in lesser than region, lesser than k. So finally what you have to return? You have to return uh, ans. Now guys, see this. So what I say here, you are using some other variable, extra variable ans. And what is this variable used for? To give your answer, and then you are returning this. Now what happens in few questions, not in few, like in many questions it will happen that there are many things that, but like there are lines you have to write just to get your answer. But what I am saying is, you already had L and H in place. Okay, I'll let you know how I like go with this. But avoid using any extra variable like ans. Keep your binary search as clear as possible, and I'll let you know how I go, and then return in terms of L and H, because you already have L and H. Let me go with that. Initially guys, when L was here, H was here. Okay, I'll say what, this is my first space, and this is my second space. Okay, this is my second space. This is the thing. So L was here, H was here. Here you see guys. So what I'm saying is, let's see where L can move finally, because obviously L was going to right direction. And when L was going to right, whenever you are getting a mid who was less than k, when you are getting a mid whose value was lesser than k, so which is the last mid? Guys, obviously mid is some value. So which is the last mid whose value is lesser than k? Because L will move in right direction now. So let's say this is the last mid. Obviously this is the last mid whose value is, this is the last point whose value is lesser than 7. Okay, because mid is some value. So this is the last value who is lesser than k, and that is obviously that is why we write this favorable. And if you see, when you land at favorable only, you will do what? L equals to mid plus 1. So finally where L will be here. Finally L will be here. Okay, why? Because if you see guys, so let me erase this thing. Okay, wait. So if you see guys properly, so L can move only when your mid lies in this region, in favorable. L can only move, and this is the last mid, because L will go to right, and this is the last mid, rightmost mid, where actually if you get this mid, then L can possibly move, and which is the last index and L can go if L is at this, sorry, mid is at this particular favorable, this rightmost favorable, then L can move one step right of it. You see, when you get a favorable, you move L to one step right of mid. Now, not this onwards, all the values are unfavorable, and you know, whenever you get unfavorable, you are not going to move your L, you are going to move your H. So you got this when you, this is the last, what is the last final placing of L when your binary search will be ending. What is the final placing of L? Now let's see for H. As H can move in left direction, it has to move from right to left, and where it will move, whenever you get a mid which is unfavorable, then it will move one step left to that mid, and which is the, because it will go from left to right, guys. It will go from left to right, which is the rightmost value if mid goes there, and that is unfavorable. So which is like rightmost unfavorable, this one right here. Okay, so at final point where h will be, because if it is unfavorable, then h can go one step left to mid. H can go here, h can go here. Okay, so if you see, and here what happens, L becomes greater than H. So this is the first point, because your condition will not be ending till L is less than equals to H. And here what happens, the first point when L became greater than H. So here your loop will be will break. And so finally you see guys, when, and see this carefully, when your loop is breaking, so your L will be at first element of second space. Okay, first element of second space when your loop, it terminates, it ended. And where h will be last position of first space, last position of first space. You see guys, L started in the favorable zone, which is the first space, ended at first element of unfavorable. H started from unfavorable zone, ended at last element of favorable. So guys, for upcoming videos I'll be using this concept LNH directly. I'll not go in this much of depth. I hope clear this point, that where H and L will be. I'll again write uh, at end L will be at first point. L will be at where first element, first index, I mean I can say first index or value at in second space. In a second, so listen this guys carefully and see this, like, and if you're confused on this why, then go back and listen what I said. And H would be at last value in first space, in first space. So guys, this is very important, because why, because I'll be using this thing directly in many of my videos and research. Because once you are okay with this, right here, if you see, you don't have to return ANS. Avoid using ANS extra variable. What you wanted as an answer, what you wanted, the last element of first space. And when your loop is ending, because you will obviously reach here return statement when your loop ended. When the loop was ending, which amongst L and H was at this position, was at last element of first space? Obviously H. So what you have to return? Directly A of H. You have to return A of H. Or if you want to return index, you can return H. In fact, only this is the value, this is the index. That's it. So this was the trick that I wanted to share with you guys. This is not actually a trick. It's like we derived it right here. Okay. Now the other thing which is not that important, but I'll let you know. So here you see guys, in the previous example where we wanted lesser than k value, the largest value which was lesser than k. Okay, largest value lesser than k. So what happens in this, by seeing just like with a naked eyes, you can see which is favorable and which is unfavorable zone. Like you can divide that directly. So you say that yeah, this zone is favorable because this is lesser than zone, lesser than zone, lesser than k. This zone is unfavorable, greater than equals to k. This is unfavorable. Okay, so by seeing your naked eyes, you decided to like divide this in favorable and unfavorable directly. So, and in your if condition you wrote na guys, that if A of mid is lesser than k, so what you do L is equals to mid plus 1, which is this is your favorable. This is semicolon guys, इतना बड़ा semicolon कैसे लगा दिया मैंने? Let me clear this. Okay, it is nice. So this is your favorable, and else H is equals to mid minus 1, and it depends on like whatever conditions you are applying here. But here this was your favorable and unfavorable. So here you see, by just looking into this mid value in this array, you decided is it favorable. If obviously if when it is favorable and it is lesser than k. So this is type 1. I call this question, this type of problem type 1, where unfavorable and unfavorable are easy to find. Here you don't have to do anything. They are like, just if you see them clearly in your by your naked eyes, you will get to know. And there exists type 2 question, which is a bit harder. The template will never change. Okay, if you are good in that LNH part, what I told earlier, just keep this template clean, otherwise you'll be confusing yourself. So don't confuse yourself a lot, keep this template clean. Now the type 2 question would be, to decide unfavorable and favorables, unfavorable and favorables, you have to write some function, right? Some functions you have to write, some functions. So here we'll be using some functions to determine should we go into this loop or not. So this would be type 2, and we'll be seeing like various problems on this type 1 and type 2. So let's go into these problems. Thank